I hope you enjoyed the small break we had before. Today we will talk about scalable, decentralized, and cost-efficient oracles. Before that, I want you to picture the following scenario. Imagine you're a craftsman and you want to build a boat. You want to build the most amazing boat out there. And you're spending months and months crafting your boat. Finally, after all this hard work, you're ready to test out your boat. But you soon realize that there is no water close to you. You cannot test your boat. Your boat is pretty much useless. When it comes to decentralized applications that use data from the real world, we have pretty much the same scenario if we cannot provide this data to those decentralized applications. Use cases such as stable coins, decentralized exchanges, decentralized insurance, and many more other need this data in order to function properly. And here is where Oracle comes into play. Oracles are the bridge that allows the smart contracts from different decentralized applications to access real-world data. A few words about myself. My name is Bianca Buzea. I'm recently joined the Chronicle team as lead DevRel. You can see my socials out there. You can also find me at the booth in front throughout the weekend, so I'm more than happy to support you with your projects. On today's agenda, we already saw the problem we are trying to solve. We want to see how we can bring this real-world data onto the blockchain. Now we're going to look why Chronicle specifically, and then we're going to have a short application. We're going to see how we can get the ETHUSD price feed on chain, and then we're going to build small dApps. We're going to have a token vendor, a smart contract, where basically you can pay ETH, and in exchange you're going to get a specific token, a token that we built before. Now, a few words about Chronicle. We are the Oracle that has been powering Maker since 2017. Last year in autumn, we spun out of Maker under the branding of Chronicle, and now we are open to the community, so come build with us. In terms of TVS, or total value secured, we currently secure over 6 billion of assets. Now, Chronicle Oracle Scribe, it's an extremely gas-efficient oracle using aggregated Schnorr signatures. Schnorr signatures have existed for a while. They were starting in 1991. They even are integrated into Bitcoin. However, this is the first time when Schnorr signatures are used in the context of Web3 oracles. Now, what sets us apart is that Chronicle offers decentralized, verifiable, and scalable oracles. And we're going to take this one by one and see exactly what I mean by this. First up, decentralized feeds. Feeds are also called validators, or as you can see, our validators are reputable players in the space, which means that they have a stake with their own reputation to make sure that the data they provide is accurate. Chronicle oracles are also verifiable. We have end-to-end verifiable data, and let me show you a brief demo of what I mean by that. So here is our website, chroniclelabs.org, and you can go to launch dashboard. And let's say, for example, I'm going to take the GNO USD. You can select on the timeline a specific date you're interested in. I'm just going to take a random one. And you can see in here the different validators that I was talking about. For each of these validators, let's say DeFi Saver, I can see one second, because I pressed the wrong thingy. Okay. Yeah, you can see in here, this is the right page. You can see in here all the different validators. And for each of these validators, you can see the actual data sources. So let's say I'm taking the Gitcoin validator. You can see all the data sources that have been used. And as you can observe, it's a mix of on-chain and off-chain data sources with very good liquidity. Another cool stuff you can do, you can verify cryptographically in your browser that the data hasn't been manipulated. So if I go here at verify, I can see that the signature is the same. However, if I modify even slightly, let's say I delete a 0 over here, we're going to see that the signatures do not match anymore. Okay, back to my presentation. In terms of scalability, because of the optimistic Schnorr signature that I was mentioning before, we are able to achieve gas cost of over 60% on L1s and 68% on L2s. And this is pretty awesome because it allows for the first time when it comes to Web3 oracles to decouple gas cost from the number of validators. As you might know, oracles are expensive. So if you are an oracle provider, you pretty much have two choices up until now. Either you increase your prices, which makes you less competitive in the ecosystem, or the alternative, you reduce the number of validators or the number of updates, which results in stale data and potential threats on security and decentralization. So that's why it's really important to be able to make those gas reduction actually within the protocol, such that you can still have this rich ecosystem of validators and actual decentralization. Now, why we're here, it's a hackathon. We're offering 10K in bounties spread across 3 tracks. The first one is the DeFi track. Here, pretty much any sort of DeFi integration qualifies. So if you want to integrate our Chronicle oracles for use cases such as borrowing and lending the apps, decentralized exchanges, liquidity mining, prediction markets, stable coins, etc. Next track is the innovation track. Here, we're looking for innovative projects, and the innovation can stem either from the utility of the project or the idea itself. And please feel free here to scan the QR code. If you scan that QR code, I'm going to wait a moment for people to get a chance. I'm going to walk you through the page that will pop up when you scan that QR code. You got it? Okay, one more moment. So when you scan that QR code, it's going to take you to this bounty page. You can see here for each of the bounties, you can see the overview of the bounties with all the details, both for the submission, both some ideas for the projects. You can see here the GitHub repository that we're going to work on today. Some more information of how to use the Chronicle oracles, resources. Very important here for resources, we have a Scaffold Oracle Reader built on Scaffold ETH2. So those of you familiar with Austin Griffith's Scaffold ETH2, we are using that to leverage for our oracle. And very important here, you have the different addresses for our oracles on different networks. So you can check out the different networks. Some of these chains are also offering bounties, so maybe something to consider. And finally, how to get help. All right, back to the presentation. Yeah, finally, the last track, and probably my favorite because it's something I think innovative that I don't think I've seen before at ETHGlobal. It's a small education track, so for those of you that, I see here an issue. For those of you that might not have enough time to build a fully fledged project but still want to contribute and to ship something, there is a small pool prize. It's $600 USD spread across 2 tracks. I still know that the numbers are a bit messed up. But yeah, if you want to build a tutorial with Chronicle oracles, this is your track to go. Now, how do I use Chronicle oracles? First step is to actually get access. So our oracles are read protected, which means that you need to be authorized in order to read from them. The authorization process is called a kiss. It's very whimsical, I know. And the good news is that on testnet, you can self-kiss. You can authorize yourself. After you authorize yourself, you are good to go. You can start using the data to power your DApp. One thing to mention here, very important, is that you need to get authorized for each oracle that you want to use. So if, let's say, you want to use ETHUSD and ETHBTC, you will need to do the authorization for each of these two. Okay, and now finally the fun part. Here is the GitHub repo that we will work with today for our project. Feel free to scan it. I'll wait a moment for people to scan it. You got it? Nice. So first step, we're going to create our own token. I was using here the ERC20 token, and I was using the OpenZeppelin access control in order to manage roles. We have two roles, the default admin role in order to create roles, and then the minter roles in order to enable minting. So the address who has the minter role can mint tokens. Then in terms of the minting functionality itself, it restricts the token minting to accounts with the minter role. And yeah, it's pretty much the classical ERC20, nothing fancy here. I put the name of the token, the ticker. Feel free to choose to customize it for yours if you follow along. And I think we're good to go to the token vendor. So the token vendor basically will be the smart contracts where we're going to send our ETH, and in exchange, we'll get this token that we just created. So for the token vendor, we're going to start by creating these four variables over here. The first one is the Chronicle. This is the price feed. Is of type iChronicle. This is the interface for Chronicle oracles. Then we have the self-kisser. This is of type iSelf-kisser. This is the interface that manages authorization for the different oracles. And then we have minter and owner. Then in the constructor, we're going to deal with the different instantiations. First one is the minter. We're going to pass the address of our token that we just created, the ERC20 token. I put here some comments. You will see that this is hard-coded for Sepolia network. However, if you're using a different network, you can just take the address from here. You can just find the address from here corresponding to the network that you're using. So yeah, here we initialize the self-kisser, and then, oops. And then in terms of the Chronicle, we pass the address of the ETHUSD. We're going to use, for this example, ETHUSD, and then we're going to self-kiss ourselves, as I was mentioning earlier, in order to be able to read from this oracle. Next step is the read function itself. We're going to read from this Chronicle that we did in the previous step. And then we have the token amount function. In the token amount function, we basically calculate the price, keeping in mind that we deal with 18 decimal places precision. If you used other oracles in the past, maybe you've seen that they have like different decimal places. In our case, it's 18 decimal places for all our oracles. Also, something important to keep in mind here, We're handling everything in integer math, so Solidity doesn't have decimals, so it's important to, for example, do stuff like multiplication before division in order to maintain precision. Finally, we have the receive function. This allows us to basically send ETH and in exchange get our token, which is getting minter. We only have a modifier, only owner, to allow only the owner, and then the withdraw function at the end, we want, after we collect all this Ether, we want to be able to withdraw it. This is it in terms of the workshop. I'm going to show you a demo of this token vendor example. This is, again, the QR code, but I think you already scan it. So I'm going to go and do the demo. I have here already the two contracts deployed, the ERC20 token and the token vendor. So the idea is now that I'm going to send some ETH from my EOA, my externally owned account, to this token vendor address. And in exchange, I should get the token that I created. So let's see that in action. Let's send, let's say, 0.1 Sepolia ETH. And after it gets minted, we should be able to see it on EtherScan Sepolia. Okay, it's confirmed. Let's view it on EtherScan Sepolia. So you can see that I received some Bianca token. If you remember, in the ERC20, I put it Bianca token, the name of my ERC20, 34 seconds ago. Yeah, it's a pretty easy example, yet powerful, to kind of demonstrate you the different functionality, how you can read from the Oracle, and how you can then integrate this into your DApp for the hackathon. Okay, I'm gonna put this. Are there any questions? Sorry, a bit louder, please.
At some point you did it at the end when you show again the here the times 18 at the end, why you don't do it before?
Yes, so as I was saying, because we don't have decimals on Solidity, so we need to deal with integer math, it's called in Solidity. And if you're doing first the multiplication, it allows you to maintain precision when you're doing the division. So usually in real life math, it doesn't really matter if you're doing multiplication or division, but here, in order to maintain the precision of the decimals, it actually has an influence. It's 10 to the power of 18. It's 10 to the power of 18, yeah, no worries. Any more questions? All right.